Good morning, students. Today we are going to solve the numerical related with the heat exchanger. Now, first of all, note down the numerical. Water at 15 degrees Celsius enters into a counter flow heat exchanger with flow rate 7500 kg per hour. It cools the air entered at 105 degrees Celsius into the exchanger. Flow rate of air is 8000 kg per hour. Find the exit temperature of the air if the air is 20 meter square and overall heat transfer coefficient is 145 watt per meter square Kelvin. Use NTU method. Take Cp of air 1 kilojoule per kg Kelvin and Cp of water 418 kilojoule per kg Kelvin. Now first of all, see, they have given the heat exchanger, and in this heat exchanger they are not mentioning the inlet and outlet temperature condition, and when we know the inlet and outlet temperature condition, at that time we can solve the numerical by using the LMTD method. But in this method you can see clearly they are not mentioning any kind of the temperature, so we have to use the NTU method, number of transfer units method. So first of all, we have to write down the given things. So first they have given TCI, which is water at 15 degrees Celsius enters into the counter flow heat exchanger. So TCI is 15 degrees Celsius. Next they have given the flow rate 7500 kg per hour. So they have given m dot c 7500 kg per hour. Next they have mentioned it cools the air enters at 105 degrees Celsius. So it is the hot air, we know that, because which is cooled, so which is at 105 degrees Celsius. Next they have mentioned flow rate of air, means flow rate they have given. So m dot h, it is 8000 kg per hour. Next they have given find out the exit temperature of air. So they are asking us to find the exit temperature of the air, and this is the things we have to find. Next they have mentioned the area is 20 meter square. So area is mentioned, area is equal to 20 meter square. Next they have given overall heat transfer coefficient is 145 watt per meter square Kelvin. So U is given. per meter square Kelvin. Next, use NTU method and Cp they have given Cph because air is hot and Cp of air they have mentioned 1 kilojoule per kg hour and Cpc they have mentioned 4.18 kilojoule per kg hour. So all these things they have mentioned and they are asking you to find the hot air exit temperature. So first of all we have to calculate the capacity ratio. C is equal to mCp small upon mCp large. So CH we have seen this terms in derivation mH into CpH. So mass they have given for the hot fluid 8000. We have to convert it because it is mentioned in kg per hour and they have given CpH now the value of CH. See, they have given the mH value and they have given the Cp of the hot air. So these values they have mentioned. So we have to calculate CH, that is the heat capacity of the air. So which comes after using the calculator 2222 watt per meter Kelvin. Next we have to calculate Cc also, that is mC into CPC. MC they have given 7500 divided by this is 00 into CPC 4.18 into 10 raised to 3. So after solving the on calculator we get it is 8708.33 watt per Kelvin. Now, so we are getting the CH and CC, so we can calculate the term C. So C is equal to, this is the C minimum and this is the C max value or C large value. So C we are getting 2222.2 divided by 8708.33. So C value we are getting 0.255. So this is the we are finding the value of C. Next we have to calculate the NTU, means number of transfer units. So number of transfer unit, that is NTU. We have yesterday we have seen the derivation, and in that derivation NTU we have calculated UA upon the C minimum. So U value they have mentioned 145, area they have given 20, C minimum we have calculated which is 2222.22. So we have substituted the values and after solving on calculator we are getting the number of transfer unit is 1.3. And once you get the NTU, you can easily calculate the effectiveness of heat exchanger. So effectiveness of this counter flow heat exchanger, 1 minus e raised to minus NTU 1 minus c upon 1 minus c into e minus NTU into bracket 1 minus c. So in this effectiveness formula we have calculated NTU, we have calculated c value, so we can easily calculate the effectiveness. So the value of effectiveness comes, it is 0.68. So this is the value of effectiveness, and we have effectiveness. Our ultimate aim is to find the exist temperature, but before calculating the exist temperature we have to calculate the effectiveness, because in the effectiveness formula we are using all the temperature terms. So it is THI minus THE upon THI minus TCR. So effectiveness 0.68, we have calculated. THI they have mentioned 105. THE we have to calculate. Next THI minus TCR 15 degree. So we have substituted the values in this formula, and after solving this we are getting the THE is 43 degree Celsius. So first of all we are going to summarize this problem. See, in this problem they are asking you to find the exist temperature of the air. So while calculating the exist temperature of the air, they have given the temperature of the water inlet, heat capacity, mass of that water, then they have given temperature of the inlet air, then mass of the inlet air, and they are asking you to find the temperature of the exist of the air. So and area mentioned, overall heat transformation, and the CPH and CPC value they have given. Specific heat of air and specific heat of water they have given. So while solving this problem, after seeing the given data, we found that they have not mentioned all the temperature, so it is impossible to calculate by using the LMTD method. Okay, so first of all we have to calculate for the unknown temperature, we have to calculate the effectiveness. Okay, and for calculating the effectiveness by using the NTU method, we have the formula effectiveness is equal to 1 minus e raised to minus NTU 1 minus c upon 1 minus c into e raised to minus NTU into bracket 1 minus c. So by using this formula we are getting the effectiveness. So in this term we require the c and we require NTU. So c we can calculate by the ratio of the MCP small upon MCP large, means heat capacity of the smaller upon heat capacity of the larger. So for calculating these heat capacities, they have mentioned the mass and specific heat. So we are, by using that terms mass and specific heat, we are calculating the heat capacity of small and heat capacity of the large. And once you getting this, you can easily calculate the term C. Next, for calculating the NTU, it is required overall heat transfer and the area and C minimum. C minimum we have calculated, and that is CH. So C minimum we have calculated. U overall heat transfer they have mentioned. Cross section area is also given in the problem, so we can easily calculate the NTU. Once you know the NTU and C value, you can calculate the effectiveness. And here we are getting the effectiveness is 0.68. Next, effectiveness formula THR minus THE upon THR minus TCE. So in this term THI they have given, THR, next TC, I they have given, and we have to calculate the THE, temperature of the air which is coming from the heat exchanger. So after substituting the terms, we are getting the temperature of 43 degree Celsius. So this is very simple numerical. Just you have to require the whenever they are mentioning the given data, and after observing that given data, which method you are going to implement. First you have to decide. In some problems they are directly giving solve the numerical by using the NTU method or LMTD method. In this problem also they have given solve the problem by using the NTU method, and we have calculated by using NTU method effectiveness. Once you get the effectiveness, we can easily calculate the exist temperature of the air. So this is the numerical we have seen. So in next lecture also we can make the practice of the numericals. So today we have completed our 6th unit. Okay. So all the syllabus of the heat transfer is we have completed during all the sessions, covered online lectures and the lectures on the YouTube also, but I am continuously putting the video lectures on the YouTube regarding the numerical related to the heat transfer. So that's all about the today's lecture. Thank you very much.